All right, welcome again, Wildcats. All right, so today we're looking at Tuesday, April 18th, and we're graphing polynomials day 1, and that's going to be on page 72. So if you would, pause the video and update your table of contents. All right, now your table of contents are updated. Let's take a look at our notes. All right, so we're graphing polynomials on page 72. All right, so name the degree. So x to the first power is linear, okay? And remember, if it's a positive linear function, the graph goes up. If it's a negative linear function, the graph goes down, okay? If it's x squared, it's quadratic. And if it's a positive quadratic, the graph goes up. If it's a negative quadratic, the graph goes down, okay? X to the third power is cubic, and if it's a positive cubic, the cubic goes up. And if it's a negative cubic, the cubic goes down. X to the fourth is quartic, and if it's a positive quartic, the graph goes up, and if it's a negative quartic, the graph goes down. So if you would, pause the video and update your notes. All right, almost forgot it. I'm hoping you got those updated, but x to the fifth is quintic, and we're not going to have a graph to quintic. I just want to let you know that x to the fifth is quintic, okay? Okay, all right. The number of turns is 1 less than the degree. Now for the x-intercepts, they're the zeros or the roots, and they're found by setting f of x equal to 0 and solving, okay? And in solving, there's 3 methods. Method 1, factor. Method 2, quadratic formula. Method 3, synthetic division. So if you would, pause the video and update that portion of your notes. All right, now that those notes are updated, let's look at it here, okay? Now, zeros, when you're finding zeros, they can have multiplicity, okay? And if the 0 has a multiplicity of 1, okay, this is what the graph will do. If it has a multiplicity of 2, this is what the graph will do. And if it has multiplicity of 3, this is what the graph will do, okay? All right. Now, the end behavior, write using infinity notation with respect to the arrows. All right, so if you would, pause the video and update your notes. All right, now that your notes are updated, let's take a look at the examples. All right, so before we go to the examples, I made a couple mistakes, and I thought about making new copies, but then I thought, let's save a tree and we can just fix it on the video, okay? So, the first mistake, this should say graphing polynomials day 1, okay? All right, there's 3 mistakes, okay? Second mistake, example 3, mark out this, and it should say negative x to the 4th power plus 2x cubed plus 8x squared equals 0. Okay, so that was mistake number 2. And then the mistake number 3 is problem number 5. So turn to problem number 5. All right, problem number 5, mark that out. Okay, and it should be negative 3x to the 4th power plus 6x squared plus 24 equals 0. All right, so pause for a few seconds and fix number 5. All right, so those are the 3 mistakes. So now let's take a look at the examples. All right, so let's look at example number 1. Okay, so the degree name. So it's 2x cubed, so the degree name is cubic. Okay, the leading coefficient is a plus 2, a positive 2. Okay, the number of turns, and I'm going to look at my notes to make sure I said it's right, is 1 less than degree, so that the number of turns is 2. Okay, it's an odd degree. Now the y-intercept is the constant, and in this case the constant is plus 0, so the y-intercept is 0, 0. Okay. At this point, we're going to identify the zeros. Okay. So to identify the zeros, you have three methods: factor, quadratic formula, synthetic division. When we always want to try factoring first. Okay. So I see here that all the terms here are divisible by 2, and an x. So we're going to factor out a 2x from all the terms. So that's 2x times x squared plus 2x minus 15. And we're going to set that equal to 0. Okay. Now we're not doing anything with the 2x. Okay. Since we know it's x squared, we have two parentheses. We know that x and x make x squared. Now we need to find all the factors of negative 15. So negative 1 times 15. Negative 2 doesn't work. Negative 3 times 5. Negative 4 doesn't work. Negative 5 times 3. Okay? So we've gone through all the combinations. So now we're looking for which combination combines to be 2. In this case, it's a negative 3 and positive 5. So it's x minus 3 and x plus 5. Okay? Now we're going to set each of those equal to 0. So 2x equal to 0. X minus 3 equal to 0. And x plus 5 equal to 0. So you divide 2 by both sides, so x equals 0. Add 3 to both sides, so x equals 3. Subtract 5 from both sides, x equals negative 5. All right, so we're only going to, in this video, just put the x-intercept as 0. So that's 0, 3, negative 5. Okay. Now, in class, I want to go over how to sketch the graph and the end behavior, but I'm going to leave that for class. Okay. So if you would pause the video and finish or update what we have for example 1. And remember, we're going to go over the sketch and the end behavior in class. All right, now let's look at example number 2. Okay, so the degree name is 4, it's x to the 4, so it's quartic. Okay, the leading coefficient is 1. The number of turns is 1 less than degree, so that's 3. Okay, it is even. Okay, now the y-intercept is the constant, but we need everything on one side before we so we're going to add 36 to both sides, so you get x to the 4th minus 13x squared plus 36 equals 0. So our constant is 36, so our y-intercept is 0, 36. Okay, so now we're going to identify the zeros. Okay, and to identify the zeros, we're going to either factor, quadratic formula, synthetic division, and we always want to factor when possible. Okay, and I think I want to wait to factor this one in class. So we're going to do the identifying the zeros, sketch a graph, and then behavior for example 2 in class. Okay, so if we would finish up updating example number 2. All right, and then example 3, we're going to do example 3 from start to finish in class. Okay, so with that gets you a start, and we'll go over the rest of the examples. We'll finish example 1, example 2, and we'll go over example 3 in class. And I almost forgot, there was 4 mistakes. And the 4th mistake is there is no example 4. So you can get rid of example 4. Okay, so no example 4. Bye-bye example 4. All right, so let me just say it again. So we'll finish example 1, finish example 2, and we'll do example 3 from start to finish in class. Remember, if after watching the video, if you want me to go over example 1 and 2 from start to finish, we can do that as well. Okay, so with that, have a wonderful Wildcat weekday.